Quiz. Oh, name my favorite student of all time. She gets everything right. It's amazing. Good old Ann Serkey. Express in scientific notation. 1 mark each. 5.5 times 10 to the 4th. 4.2 times 10 to the negative 2. Yes? 3.64 times 10 to the negative 1, 2, 3, 4, 5. Negative 5? 1.236 times 10 to the 1, 2, 3, 4, 5, 6, 7? 1 mark each. We're going to go to our calculator. Correct number of sig figs. It says express your answer in scientific notation. Really? Had to tell you to get the headphone out of your ear? If it's a number close to 1 and it's more work to write it in scientific notation, I don't freak out if you don't bother. But if it does say 2 in a test or a quiz, we'll have to. Okay, here we go. Practicing our calculator. Number 1, 7.1, scientific notation button, -4. And remember, Tara, I don't hit the times or the 10 or the to the power of. It does it all for me. It's great. 3.6, scientific notation button, -7. You get 2.556 times 10 to -10. Now, that's the answer on my calculator, but it does also say to the correct number of sig figs. Riley, how many sig figs in this first number?
2.
How many sig figs in the second number?
2.
How many sig figs in my answer? Because the multiplication division rule says go to the fewest number of sig figs in any of your data. So it's going to be 2.5 or 2.6? 2.6 times 10 to the -10. Now, if you botch the sig figs, you get a half mark. Yes?
When I first did it, when do we use on homework sheet A here? It tells us to
I wouldn't use that method.
No. It
No.
tells us to take the.
I wouldn't.
7.1.
That's why I never taught that method, and I actually said just ignore that method. I just gave you the questions for practice.
Oh, okay.
That's how you would do it in the pre-calculator before you had an easy calculator count of a day.
Okay.
Use your calculator. B. 1.42, scientific notation button, -5, divided by 4.3, scientific notation button, -15. How many sig figs in the top number? 3. How many sig figs in the bottom number? 2. How many sig figs will I go to in my... It's going to be 3.3. 2 sig figs. 3.3 times 10 to the 1, 2, 3, 4, 5, 6, 7, 8, 9? Perform the following operations and show your adding and subtracting is tougher. First of all, you can just get the answer. That's step 1. 6.0, scientific notation button, -3, plus 3.5, scientific notation button, -4. That's sort of the answer, but for adding and subtracting, what you really need to do is you need to write them out in standard form, above each other, lining up the decimals, and you don't round off to 2 sig figs. You don't round off to 2 sig figs. You look at how many decimals that you know for certain. In other words, somewhere off over here in the margin, I'm going to write out 0.060. That's that number. And underneath it, I'm going to write 0.00035. That's that number. Now I'm going to add. What am I going to round off to? I'm going to round off to this decimal place right here because I know both of those. The first number was a 0. The second number was a 3. So I'm going to round off to 4 decimal places. I'm going to round off to 1, 2, 3, 4 decimal places. That 3, is it going to stay a 3 or become a 4? So the answer is going to be 0.0064. Now they did say to go to scientific notation, 6.4 times 10 to the -3. It says 2 marks. How would I give 2 marks out for that? I don't know. I'd make this worth 1 mark, but that's okay. What's easier, multiplying and dividing or adding, subtracting? For sig figs, multiplying and dividing. For actual arithmetic, adding and subtracting. Most of you can add stuff in your head pretty good. But when it comes to sig figs, multiplying and dividing. Conversions. 3 seconds into milliseconds. I'm going to use my chain method, so it's going to be 3s on top. So I want an s on the bottom and an ms on top. Milli is 10 to the negative 3. That always goes next to the base units. I'm going to go 3 divided by 10 to the negative 3, which I think is 3,000. Is it 3,000? Yeah. Milliseconds. Or 3 times 10 to the third, if you wrote it in scientific notation. 25 kilograms into milligrams. This is going to be a 2-step question. 25 kg times, so I want kg to cancel. I can go to grams. The prefix k on my formula sheet, hey, that's a 10 to the third. Times, now I want grams to cancel. I want mg on the top. The prefix lowercase m on my sheet, that's a 10 to the negative 3, and that's going to go, let's make that a little larger, Mr. Duick, so people can actually read. That's going to go next to the base unit, next to the grams. It's going to be 25 times 10 to the third divided by 10 to the negative 3. It's going to be 25 times 10 exponent button 3 divided by 10 exponent button negative 3. And remember, Tara, this is not scientific notation, so I'm not going to be using the EE or the X button. I'm going to use 10 to the power of, because this is not scientific notation. It's got 10s in it, but that's because the metric system is based on 10s.
Could you use the XP button?
If you get the right answer, but I think you're going to often end up with an extra power of 10 without realizing it.
Oh,
You're going to get, I'm going to write this in scientific notation, I think, 2.5 times 10 to the 1, 2, 3, 4, 5, 6, 7. A 25 with 6 zeros, or 2.5 times 10 to the 7th milligrams. Now, I'm going to let you know I'm also going to be fussy. I'm not going to take marks off on the quiz, but on the test, if you don't write the units, you'll lose a half mark. So, you know what you do all year long on every single test before you hand it in? You go back and you look at every single question and you make sure you have the units attached. And on this test, you'll make sure the sig figs are right. For the rest of them, I won't care. 1 year into seconds. Okay. 1 year. I want years to cancel. I can go to days. I know 365 days is 1 year. I want days to cancel. I can go to hours. I know 24 hours is 1 day. I want hours to cancel. I can go to minutes. I know 60 minutes is 1 hour. I want minutes to cancel. I should call minutes M-I-N because M is meters. Seconds, and I know 60 seconds is, it's going to be 365 times 24 times 60 squared. $31,536,000. If I write this in scientific notation, it's going to be almost as long as writing the original number, because I'm going to have to write the 3, the 1, the 5, the 3, the 6, and you know what? So I'm going to write the original number. 31,536 3 zeros. 31,536 zeros. 3.1 times 10 to the 1, 2, 3, 4, 5, 6, 7. 3.1 times 10 to 3.1536 times 10 to the 7. Turn the page. It says, perform the indicated operations with the correct number of sig figs. Multiplying, that's the easy one. 0.625, 3 sig figs, 2 sig figs, 2 sig figs. 0.63, yes? 6.3 times 10 to the negative 1 if you wanted to write it in scientific notation, but I think I would never write that in scientific notation. 51.3 times 3.94. 200, let's see. 3 sig figs, 4 sig figs, 3 sig figs. 200. and 2. 4.37 times 10 to the third divided by 0.008560. I get that. 3 sig figs on the top, 4 sig figs on the bottom, 3 sig figs in my final answer. 5, 1, am I going to leave this a 0? It's going to be 5, so you can either go like this, 5, 1, 1, 1, 2, 3, or 5.11 times 10 to the 5th. That's right about where it's the same amount of work to write it out or do scientific notation. Am I wrong? Oh, adding and subtracting, way tougher. Write it out vertically. .002 0.12378. So I'm going to round off to that decimal place. Let's go to my calculator. And I'm going to round off to the third decimal place. I'm going to round off right to there. That 5, is it going to stay a 5 or is it going to become a 6? Become a 6. So 38.126. Subtraction, same idea. Write it vertically. I'll do it over here. 512.06 take away 65.2. I'm going to round off right to there because that's the last place that I know all of the decimals. 512.06 take away 65.2. I get 446.86. I'm rounding off to the first decimal place. I'm rounding off right to there. 446.9? It is. Let's do some zookeeping here. We want to change 48 parrots into lions. Let's see. Well, I want parrots on the bottom, and they first compare parrots and zebras, so I can use that. And apparently 5 of those is one of those. I want to get rid of zebras. I mean, who wants zebras? And I go to monkeys, and apparently 1 zebra is 8 monkeys. I want to get rid of monkeys. I can go to gorillas. And apparently 6 monkeys is 1 gorilla. And I want to get rid of gorillas, and I can end up in lions. Oh, great! I'm going to end up where I want to. And apparently 2 lions is the same as 5 gorillas. So I think I'm going to go 48 times 8 times 2 divided by 5 divided by 6 divided by 5, ignoring all the ones. Yeah? I'm going to go, yoink, 48 times 8 times 2 divided by 5 divided by 6 divided by 5. And it turns out that 48 parrots are worth, oh, what did I say to round to in the question? Gee, do you think I did the math first and then said, oh, it goes to 2 decimal places? Why don't I tell them to round to 2 decimal places? Maybe. 5.12. Is that right? 5.1, not 1, Mr. Duick. 5.12 lions. Who knew that 48 parrots could get you 5 lions? Turn the page. Graphing. A and B are in slope-intercept form. Woohoo! C is not. D is. Woohoo! Let's do A first. First thing I do is I graph the y-intercept, which is -4. So I'm going to go dunk right there. 4 down. What's the slope? First of all, what number is in front of the x on the top there? It's invisible, but there is a number there. Yeah, the slope is 1 over 2. Positive or negative? Positive. So I'm going to go up 1 over 2. Up 1 over 2. Up 1 over 2. Up 1 over 2. For the test, if you don't have a ruler, use one, get one, borrow one. I have some over there. I'll try and do, oh, I know what I can do. Cool, 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 cool. Uh-huh. Come on. Yeah. There's line A. The way I mark this, 1 mark, or half mark for getting the y-intercept correct, half mark for getting the slope correct. B. I'll change colors. Y-intercept of 1, 2, 3, 4, 5. Slope of negative 2 over 1, that means down 2 over 1, down 2 over 1, down 2 over 1, down 2 over 1, down 2 over 1. Let's try that again. Come on. It's not quite what I wanted, Mr. Dewick. Let's get rid of that, first of all. Come on. There. That's line B. What's wrong with line C? So let's get the y by itself. First, I would like to move this 3x over. What's in front of the 3x, positive or negative? How will I move it over then? I'm going to subtract it from both sides, and in fact, when I do that, I'm going to get this. I'll get a negative 2y still left over here, but I'll get a negative 3x and a positive 4. What's the negative 2 doing to the y? Adding, subtracting, multiplying, or dividing? So how will I move it over? I'm going to divide everything by negative 2. When I do that, I'll get y equals, I get a negative divided by a negative, that's a positive. And I get positive 4 divided by negative 2, which I think is negative 2. I'm going to get a y-intercept of negative 2. I'm going to get a slope of up 3 over 2. Up 3 over 2. Up 3 over 2. And I can back 3 down 2, or down 3 back 2. Like that. There's line C. What about line D? What's the slope of line D? What number is in front of the x? Yeah, that's why there is no x. What is a slope of 0, vertical or horizontal? What's an easy way to remember? All lines are straight, Captain Obvious. That's why they're lines. Otherwise, we'd call them curves. Straight line. Here's how I remember it, in all honesty. I always visualize a skier. If a skier is on a horizontal slope and the skier doesn't push, how fast will a skier go? Nothing. What's that as a number? 0. If it's a vertical slope, what will happen to a skier? Skier dies, undefined slope, infinite slope. Skier stops, slope of 0. That's what I always teach my math tans to help them keep it straight. And I get a kid and I get them into a tuck ski position and, push them over. It's lots of fun. Anyways, oh, what's that 6 then? I heard it. It's the y-intercept. It's the y-intercept. This is going to be a slope of 0 and a y-intercept of 6. It's going to look an awful lot like this. 1, 2, 3, 4, 5. Let's go black, Mr. Dewick. 1, 2, 3, 4, 5. It's going to go through there. It's going to look like this. Like that. That graph shows up a fair bit in physics, actually. If you get that graph, we call that the constant graph. It means whatever you're looking at is not changing for that section. Constant speed or constant acceleration or whatever. The last two, give the equation of the following lines in slope-intercept form. Now, on your quest, which we're going to start in a few minutes, you are going to be given a question like this. However, you will be having to graph the data yourself first. Callum, when you're going rise over run, when you're doing the slope, make sure you don't count squares. Make sure you look at your scale, because each square on your scale, I almost guarantee, won't be 1. You might be going up by 50s or by hundreds, or by twos, or by five. So just make sure you take note of that, right? Here, I looked at the x and y axes, and we are going up by ones. Okay. Line A, first thing I want is the y-intercept. -5. What's the slope? Up 1 over 1. Up, you know what? It's 1x minus 5. Half mark for the... Oh, do I need to put the 1 there? So you can. It's not wrong. Anyways, half mark for having that. Half mark for the y-intercept. B. Y equals, what's the y-intercept? +5. What's the slope? Negative, downhill. If I go rise over run, there's two good points to go rise over run between. I think the slope is down 3 over 2. Don't forget to put the x there. Half mark for the -3/2, half mark for the +5. Half mark off if you forgot to put the x there. Can you give yourself a nice, clear score out of 25, please? If you need to lawyer with me, now is the time.